Welcome to our EARTO webinar series on standardization for practitioners, especially researchers. Again, my name is Knut Blind. I'm from the Fraunhofer ISI and also professor at the Technical University of Berlin. Since I'm not knowing who was here the first time, just again a little bit background on the whole initiative, and the background is an EU project, EDU4Standards, and within this project, what we are doing today is a pilot addressing researchers which are affiliated to EARTO, the European Association of Research Technology Organizations. But I know also there are other researchers joining because the invitation has been shared to several people. Very briefly, what is EDU4Standards about? In general, the objective is to really empower European kind of experts in standardization, especially to represent European interests and values. Especially values is a topic because standardization is not anymore just a technical issue, and we will also address that within one of the webinars. The project has 5 objectives. It's about developing and disseminating teaching material, and I shared with you the link to the homepage where you can also see the different repositories. Then we are organizing academic standardization days, especially in universities. We did also one here in TU Berlin and other kind of cities, Madrid, Milano, Stockholm, etc., etc. Then we want to push the number of higher education institutes and universities offering teaching in standardization, increasing also the number of teachers and especially students attending the courses. And finally, our project partner, SEN, the European Standardization Committee, is responsible for setting up a standardization association. Okay, after developing a teaching concept, also running these other activities, we are now focusing on pilots, and pilots are addressing bachelor and master students in company training, and the one we are today here with concerned is the EARTO kind of community. I'm trying to get a little bit closer to those who are interested to the topic of standardization. And we have kind of 3 target groups in general, and that's the baseline, and especially the last lecture, last Thursday, and today's lecture is really addressing just the beginners, to really just set the base. What is standardization? What are different organizations? What are the processes? That was the topic of last week's webinar. Today's week's webinar is addressing the different kind of functions of standards, because this will also then set a little bit the base then for next week's webinar, which are then getting more interesting, for the role of standards and standardization for researchers. That's more at the intermediate level we are going to address, both addressing the interface between research and standardization on the one hand, and on the other hand, also then the role of intellectual property rights, patents, but also others in standardization processes. And the last 2 webinars are getting a little bit more sophisticated in the sense that we are then also addressing topics like the interface between open source and standardization. That's an interesting topic. And the final one is a little bit the more strategic one, talking about standardization in the context of technological sovereignty of Europe, but also in the context of securing European interests and values in especially international standardization processes. And that's a little bit what we are targeting. That means that's the target group. And in this context, we are now today at the module 2 on types and impacts of standards. and this will be then continued the next 4 Thursdays. And also maybe an interesting contributor will be Mirko Böhm from the Linux Foundation, talking about open source and standardization. And then also in the last lecture, we will have a guest lecturer from the University of Graz, Barbara Reiter, who is very concerned with the topic of ethics in standardization. That's a kind of brief intro, and sorry for the repetition for those who have been here last week. But as I said, the audience is a little bit changing over the webinars. Now, what's today's topic? Today we talk about types and impacts of standards. This has been a little bit touched last week already when we talked about different standardization organizations and also different ways to create standards, either in a very formal way via ISO at the international level, but also maybe national institutes, AFNOR, DIN, BSI, UNI, etc. in the different member countries, and also maybe industry consortia, and even kind of single companies creating de facto standards. Therefore, this was already touched. Therefore, the main focus will be on the effects of standards, differentiating different functions, because I think that's also then interesting for your work, and we will then continue in the next week these kind of different effects for researchers and those people developing products, processes, and trying to bring them to market. That's a little bit the objective. It means these are the 3 topics we are going to address today. As last time, we refer to a book which has been published by ETSI in 21. But I also did some overview on different impacts of standards, which will be also the base for next week, for ISO, which is also public available, which is a little bit summarizing the different effects of standards. And but we also kind of updated this with specific examples coming along in the last few years. Now, what is the focus? Really to know a little bit more about the different functions of standards, and then we go into detail in the categories we use, which are quite established. There might be some other typologies, but we use the one which is a little bit based or has its origin from economists working on the topic. And then also to have some examples how to apply this typology to different contexts. Now, about the intro, standards are used every day in our private and professional life. There are even standards for toothbrushes, and you use all kind of mobile phones, which will be an example also in the lecture, and also in professional life you use standards in very different contexts. Therefore, they are there, but not really very visible. But in some products you see on the back to which kind of standards maybe specific products comply to. And the other point is society uses standards since thousands of years. Especially at the very beginning, it was about weights, weighting kind of gold and other precious substances. Issue of distance and length was also a topic at the very beginning. And it means we have common reference systems which are agreed within and also across societies. We have a measurement system which is agreed in at least large regional parts. There are other kind of agreements in other parts of the world, but that's an issue. We have a time system which is also kind of agreed on. Would we have different time zones and etc. But overall, these are really very well established standards, which are very old and established and also not really questioned. Now, but we are a little bit more concerned with the dynamics and in general, what we see and our audience is our daily work. We are kind of confronted with rapid kind of progress in science and technology. And this is certainly kind of pushing the need for new standards, but also to update existing one. And next week we will also a little bit go into very new areas like quantum, etc., where there are initiatives to develop whole roadmaps for standards. Similarly, the topic of artificial intelligence has entered the standardization scene also almost now 5 years ago. And here the very rapid kind of dynamic development of AI, quantum is a driver, and therefore we see especially these high dynamics in ICT. And in addition to these kind of technology-driven aspects, there are also market-driven aspects and maybe also currently maybe geopolitically driven aspects like cybersecurity, which is a big topic. That means here the new technological opportunities are used to create threats used also in very sophisticated forms of wars and military interventions. That's the tension, and we will talk about this next week in detail. However, standards are key to boost the progress for the development of these new technologies. That means without standards, it will be difficult, and also scientific development might be hampered. And at the end, when I would now talk to more people being in business and markets, then also here the creation of new markets really crucially depend on the development of standards. About definitions, there are ISO definitions, but the standards is maybe very widely agreed as a kind of a way to do something, and this depends on in which context. If you think about market, it's about maybe designing products or building processes, implementing procedures, delivering services, but also doing research, and therefore standards are there. That means there are benefits, and we will see later what these benefits are, which are really crucial, especially in very complex technological systems. Are standards crucial, and they wouldn't work. And we will see later also some examples where maybe the world of standardization is not as good as it could be. That means here are some examples. If you're looking at your keyboard on your laptop, on your pad, there's a certain ordering. There's slightly differences, but really very small differences. But in general, the keyboards are standardized, and it's following a specific kind of order which has been established now since 100 years, something like that. Then also connectors and chargers. here we have examples where it's well aligned, but there are also examples where it's not kind of so aligned, and we need either adapters or it just doesn't really fit together. We might have to buy a new charging system. And also in the context of software protocols, we are agreed on that. Last week, we really went into the different kind of procedures, how to develop standards, and in general, we are focusing also today on those standards which are produced by so-called standard development organizations. Here, ISO, IC, ITU at the international level, ETSI, and like here at the European level, and at the national level in AFNO or BSI, as I said before. And then there are de facto standards, which are really maybe the outcome of competition in markets where maybe one or maybe a group of dominant companies were able to implement the standard, create critical masses, and then at the end, everybody is following these types of standards. There are also some examples where then de facto standards became then formal STO standards, for example, HTML and PDF at the very beginning were de facto or consortia or company standards, but then eventually they were then transformed to a higher level. That's just a brief replication. In our lives, we are using smartphones or laptops, and here is just an example that different types of standards are necessary to make these systems working. Here you see that you need standards for the network, that means for the Wi-Fi network, for the internet. Then you have specific applications. You have specific standards for mobile networks, and here 3GPP is an important player. And then also at the user terminal, you have standards, you have connectors, and all these kind of have to interact in a specific way. But they have also different kind of functions. Some are more kind of necessary to get the things connected. Others are a little bit more focused on safety and security aspects. And as you will see later, therefore, it makes sense to differentiate a little bit the different types of standards, but at the end, they work together. Just to exemplify this a little bit, a colleague from the US, 15 years ago, they really kind of tried to find out what is the number of standards, and they just focus on the interoperability standards within a laptop or a personal computer, and they found more than 250 standards, interoperability standards, which address topics like the display, the graphics, the sounds, the power, etc., within the laptop. And they say, okay, this is maybe the lower bound, and in general, you probably will talk about even 500 different standards. And then they looked really at each of these standards, and the very big majority were really developed by the SDOs. That means here ISO, IC, etc., and ETSI, but 20% were individual company or de facto standards, where especially maybe big players like Intel had some specific standards. Yeah, that just shows the complexity of a specific product. If we are looking at another kind of example, which is quite simple, I mean, switching on lights here, especially the standards are developed by the electrotechnical committees, IEC, at the international level, and in Europe, ETSI and CENELEC are providing these standards, and here standards which are responsible for the generation systems. That means here for kind of generating the power, and then you have standards for the transmission and distribution of the power, also assuring specific level of quality. And then you have within your house IEC standards for electrical installation and for buildings, which is another kind of family of standards. And then at the way, and this allows you then to kind of switch on the light and switch it off without really facing harm and danger for you. These are just the intro and some basics for standards in our everyday life. Now trying to be a little bit more systematic, we will go through this type of this typology of standards, and in general we make a distinction between 4 types of standards, and we start with maybe the one which is most common for the information and communication world, but since IT is entering also other fields, this makes sense to look at compatibility and interface standards, and we look at the pros and the positive effects, but standards can also have negative effects. The other types are the quality and safety standards, which are a little bit different in other contexts than standards per se, and maybe every standards, and therefore this is a little bit the kind of baseline function is that they reduce variety. And finally, but this has also pros and cons, because we also like variety. And finally, standards provide information and can be used also as measurement devices, and they're based for measurement. And in the ISO publication I did, you find a little bit the overview. There's a first, another 5th element I'm not going into today. Maybe we can talk about this next week because it has a specific link to research. Now, this is double. Sorry for this. I think, let's start with compatibility and interface standards. And as you see here, network externalities, it means really the benefits we generate when we are connected in networks, and which allows us to be connected or get connected, and this follows a non-linear relationship. That means the more participants, the exponential is the potential kind of number of connections we get in. Another important aspect is that we avoid a little bit of login in old technology if there's a backward compatibility to previous technology. For example, the different generations of mobile communication standards from 2G, 3G, 4G still allowed us to get connected and kind of phone people who might have lower levels of previous standards. Then also the variety of systems is kind of increased if we have these standards. And again, think about these 250 standards in a laptop. There are different components integrated in a very complex system, and this leads then at the end to an increased variety for the producer, because they can then kind of purchase individual components from different suppliers, which at the end allows a bigger variety. And these standards also increase the efficiency in supply chains, because here the point is that in supply chains more and more specific suppliers really address very specific niches in supply chains. And if they are all really, the interfaces are all well defined, then the efficiency in these supply chains are increasing, and which makes at the end it possible for those which are putting the products together, be it a laptop or being in a car, to be much more efficient. these standards are negative or could really be misused if especially single players dominate them. And in the past, especially big US companies are here to be mentioned, which had the market power to create very specific company standards, and be that Microsoft, IBM, and Apple, and we'll look at some examples later. Then these kind of dominant position, which are sometimes complemented by intellectual property rights, are then creating strong market position, even monopolies. And then what we all know is if there is just one provider of a product, then they are misusing their position by kind of asking for higher prices than we would normally pay in a more competitive market. But also if these monopolies are a little bit getting lazy because there's no really pressure to invest also in innovation, there might be also slowdown in the dynamics of developing new and innovative and better products. And another negative aspect of compatibility standards are a lock-in into old technologies, especially when we have very strong network externalities. That means we have all agreed on a specific standard, and why should we kind of switch to a next one? Here a very coordinated effort is needed, and I will show you also later some examples where we still face this kind of negative aspect of having compatibility in there. It means compatibility is really is one very important aspect of standards, especially in the IT field, but also in the very kind of very complex technologies, where compatibility is key. Also, when technologies have to converge, that's also an interesting aspect, because here standards can help to really help to realize the converging of different technology. Within a specific standard, compatibility is also defined in two sub-characteristics. On the one hand, it's the coexistence. That means especially in a product shares a common environment and resources with other independent service and products with adverse side effects. That means you really can have these different components within this common aspect. But more important is the interoperability. That means you use the different components and put them together in the best way to increase and improve the performance of products. And especially in the ICT sector, here these compatibility and interface standards are key, and especially for the markets and at the end for the customers, and also then reversely for the producers. It's very important to consider two effects. The one is the so-called network effects. Means the more user you have, the higher is the value of the network or of the system, because you can communicate, you can exchange data. And another aspect is switching cost. It means if you are used to maybe to a specific software program, which represents a de facto standard, then you have some cost if you switch or have to switch to a next generation. Also, when new functionalities show up in some updates, you are a little bit struggling. Therefore, if both exist, then another negative effect of standards come into play, which I already mentioned. That's this so-called lock-in effect. That means you are locked in an old technology because everybody is using the same kind of interoperability standard. and we all face high costs of switching to a next generation of standards and technology. Yeah. Network effects are also to be differentiated in two types. There are the direct ones, which means the more users of a telephone system in the past, and the email, now Facebook, Twitter, or sorry, X, after this, but also other social media. That's a quite kind of simple network effect, because it's a direct one. We interact, and with the number of users, we have this exponential increase of potential relationships or people we can contact. They are quite obvious, but also very important, and partly a little bit sometimes more difficult to achieve or to exploit, are the so-called indirect network effects. That means here the value increases if you have complementary components or compatible components. And kind of the classical, also theoretical example is the linkage between computer hardware and software. This was a more historical example in the past, where the idea is that the better the capacity of computers, storages, process speed, etc., the more sophisticated software you can run on the computers. On the other hand, if there is very sophisticated software, then the higher is the incentive then also to produce more powerful hardware. In the gaming industry, you have the games and the hardware, and then also the games. And for cars, and now the actual example is electric cars, it's important to have charging systems. And the charging systems need a sufficient number of cars. Otherwise, it doesn't kind of make sense to make these heavy investments. And whereas the direct network effects can be exploited maybe by one industry or companies in one industry, these indirect network effects also require then the agreement, the consensus with other complementary industry, for example, the energy industry, for example, in the development of the charging systems and the plugs for electric cars. There was a big fight between Germany and France, because here also the very important role of the energy providers in France was a reason why France wanted a little bit different plug for electric cars. At the end, the European Commission kind of endorsed the German solution, and then this was realized. That means compatibility is key. Switching cost. In general, you have switching cost when you switch from one product to another one. But if here interfaces or compatibility standards are relevant, then there are additional costs. That means it's not only about kind of buying new equipment. You might also have to be trained, because you are maybe used to an existing software standards or to an existing standards also for hardware. You know how to use it, but if now this has been changed to a next generation, to another generation, then this comes with additional cost. And then also, if there's some kind of uncertainty whether maybe the next generation serves your needs as good as the previous one, then also some uncertainty is there, and then you have to do some tests. And this is always kind of creating costs, and these costs might so high that you are getting locked in old technologies, because coordination is needed. That means everybody, either there's an agreement that everybody changes to the new technology, and in addition, the switching cost should be not so high. That means here issues like also public subsidies might be a topic, and in the change from the combustion engine to electric cars, this is certainly also rational, or has been rational for subsidizing kind of the buying new cars. It means that's an issue, and if then these standards are owned by single organizations or consortia, then in general, and there's also empirical evidence we found, is that they want to keep the old standard because this creates their market, and they probably also get monopoly profits out of these old technology, and everybody is locked in, and nobody is going to make the change. That means this is also a barrier to entry. It's very difficult for newcomers, especially small startups and small companies, to enter these markets, and at the end we might really face a monopoly. And there are some famous examples, and this one you all know, that we have different plugs and sockets to connect our electricity products to the power. And UK, this was kind of started first, and then they introduced in 1985 a 2-pin plug and wall sockets, and then a 3-pin plug, which had some more higher level of safety, and then in 1915 the UK introduced a first standard, and then other countries followed with their national specific solutions. And at the very beginning, when we didn't travel so much, and the exchange of products was low, there was not really a big issue. But then especially after then the Second World War, and then the increasing kind of trade movements, travel movements, tourism went up, there was a concern. And there was indeed then the initiative by the IEC only in 1986 to make this IEC 6902 to make it to a European standard. But this was never realized, as we see. That means here, this is a very kind of explicit example of a lock-in which we face every time when we maybe travel to a country which has another plug system. That's one hardware issue. There are also login examples in the software area. Microsoft is an example. It means Windows is very strong, and they are quite kind of closed with making this open accessible, and this helped them to maintain their kind of strong position, keeping the network effects, maybe also expanding them, and block competition. There are efforts, especially from the open source world, to challenge this, but not really successful. And also here the proprietary use of other rights, copyrights, patent, etc., pushes this login effect. Apple also, there are some examples in the past where they tried to create logins in their digital rights management for their music, and that means here this is another example for US big companies which was able then to control this market. Meanwhile, with Spotify, we have some competition. these are just some historical examples. That means open standards are important, and here, especially with Microsoft and Apple, there are two examples of closed standards. That means openness is key. That means the process should be open. We talked last week about the WTA principles, and we just repeat them today. That means the process should be transparent, open, impartial, consent-oriented, efficiency oriented, and lead to relevant and consistent standard. And also the output, and we will talk next week, and especially in the fourth lecture about intellectual property and standards, that here also it should be open. With an open standard, the risk of lock-in is not zero. It's especially if you remember the plug example. There were efforts and there were open standards, but the lock-in is still there. But in general, it's at use because the standards is accessible, implementable, and everybody can use it. That means the entry barrier is low. The switching cost for a consumer is also low. Therefore, that's just one important information. And finally, these compatibility standards also helped to reduce the transaction cost. That means here, if the buyers know that a specific piece of software is compatible with a specific operating system, the burden to verify that the software will run as expected is significantly reduced, and these transaction costs or low transaction costs also facilitate division of labor. It means here, again, coming back to the laptop or computer examples, there are components from all over the world, and these internationally accepted compatibility standards lead to the globalization of the industries, and producers specialize in specific parts in the value chain, which makes then both the cost but also the efficiency, the productivity of the complete product much more much better than without having these division of work based on these compatibility standards. That's on compatibility standards, and that's also the most important standards for the IT world, but also for especially complex technologies. Nevertheless, there are also other types of standards we have to have a look at, especially if we consider kind of risky technologies. Then this is a topic, and here the minimum quality and safety standards have to be mentioned. Because these standards, and I will explain that a little bit more in detail later, they avoid a so-called adverse selection that at the end maybe we are faced with a market where only kind of bad or low quality is offered. They create some trust among the consumers, and again, they reduce transaction costs. However, also they can be misused. Here, the topic regulatory capture is maybe one, if maybe specific suppliers dominate the standardization processes and manipulate that in a way which makes it favorable for them to implement the standards, but negative for the other ones. That means this is then also creating barriers to entry. Now, looking at this minimum quality standards, and sometimes they also closely linked to regulation. They identify a minimum kind of level of requirements for products. In general, it's about safety, could be also reliability, durability of standard of products. And this is good for the economy because here accidents are maybe reduced. The risk by the buyers that they maybe get harmed is reduced, and the trust is increased also between consumers and the suppliers, but also in the business to business market. That means here that's positive, but if they are really kind of defined in a way which makes them very demanding, that maybe only very few, or at the end maybe only one company can comply with that, then it creates market entry. Also kind of environmental externalities like CO2 emissions can be kind of organized or regulated by a standard, especially when then the standards is referenced or adopted by regulation. Then it's a compulsory standard, and everybody who wants to enter the market here, for example, car producers, have to comply to this standard. In general, consumers are faced with a high variety of different products, and they have really sometimes a hard time to find the right one. And here, if they cannot really distinguish also the quality between high and low quality, then so-called reference law might come into play. That means if we as consumers are not able to distinguish high versus low quality products, we have to guess, and then we maybe pick the cheaper one. But those which provide higher quality have to ask for a higher price. And this drives then at the end the good quality out of the market, because only then the low quality products will be in the market, because they can afford then also this heavy price competition, and then therefore the market for high quality might disappear, and we will end up only then with low quality product. It means that goes back to the problem of information asymmetry. It means here, especially if the supplier or the seller has more information about the quality, then the buyer has problems to make really the right decision. And these minimum quality standards can at least provide some baseline, that the buyer can be sure, okay, there's a minimum quality in the market assured by the standards, and the kind of promise of the companies to stick to these standards, and that's is possible. And then maybe in addition to these baseline standards, some premium providers then can promise that they provide higher quality, and even then premium market segments can survive. Also, other mechanisms like guarantees could work as a substitute for these quality standards. Finally, these standards reduce transaction costs. That means here the search costs for products, and therefore the buyer's risk is reduced, and they also spend less money for searching the right good, and this makes the market more efficient. Certification could be also an additional kind of signal or proof for the compliance of a specific provider to a minimum quality standards. For market entrance, in general, these minimum quality standards level the playing field. That's good. If they are not there, then incumbents have in general an information advantage over the companies entering the markets in the first time. However, if especially these quality standards are set at a very high level, then it's becoming negative, and they might be a cost burden for all, but especially for the new entrants. And therefore, this regulatory capture is maybe a threat, where then the incumbents push the quality level to such a high kind of demanding requirements that it's difficult for entrants to comply to them, and that's this regulatory capture argument which makes them these standards negative. So to move on, because only 10 minutes left, standards reduce variety, which allows them to create economies of scale. focus building kind of critical mass, but the negative part is the reduced choice. And also here they can lead at the end to monopolies. Variety reduction, and in Germany the most famous standard is the A4. That means the paper format, which allows then really economies of scale. Means companies focus on a very small set of variants or types, and then can really go into mass production. This makes them cheaper. Also, the transaction cost for customer is reduced because they have not to choose between a very big kind of a variety of different products. That means we have a less fragmented market. There's maybe also joint vision. And one example of such a joint vision is the decision in the early 90s for the GSM standard in Europe, which then allowed then also not only network effects, but also this kind of joint vision. And one example of such a joint vision is the decision in the early 90s for the GSM standard in Europe, which then allowed then also not only network effects, but also this kind of economies of scale, because then everybody used the same technologies. Less fragmentation is also less risk, and also the barriers to entry might be reduced because here small entrants are able to get into the market. However, in some markets there are strong preferences for variations, especially in the fashion industries. I think they would be not so happy to have just maybe a very limited number of variants. Therefore, that's a little the baseline, and I'm not going into that. The last types of standards is information standards, because every standard provides information, helps to kind of facilitate trade, reduces transaction cost, standards like patents contain information which can be used, here also processes or best practices can be shared with others, and that's kind of a very important function of this type of standards. They disseminate knowledge, and maybe next week I can also share a new paper about really how we see that in research, and this knowledge sharing creates better competencies. Also levels the playing field for incumbents and entrants, reducing information asymmetries and barriers to entry. And this is also kind of quite important. And also the transaction costs are between, also in the business to business context, is lowered because by writing job description or contracts, you refer to specific standards, and the details are then specified in a standard. And this also then allows much better division of labor also in value chains. And that's very important. Examples, image and video processing applications in 1990s, and then the JPEG group created these standards, and also then helped to save storage space and reducing transmission rate for industry, and then many software products are then based on these common compression methods, sharing digital images, remote sensing, archiving, etc. And that's also kind of a very important baseline function of standards. To sum up, we have different numbers and different types of standards, and in general, not only laptops, but also in other very complex products, numbers, even hundreds of them are implemented. And this kind of, since the complexity of products is going up, this is even kind of becoming more relevant. On the other hand, I think I try to show that there are different types of and function of standards, and especially in very complex systems, again, compatibility and interface standards are key. And especially in the IT world, we wouldn't be at this stage when we wouldn't have standards, especially also common global standards, which allow us to use our mobile phone all over the world, and not like at the very beginning, maybe even in the US, switching mobile phones if you move from one state to another one, and also in Europe it was not a common ground. Now we have that common ground, which also then has been then leveraged to other technological areas like social media, etc. Therefore, they are really very, very prominent. However, safety and quality is also an issue, especially in very risky contexts, risky technologies, both technologies and products generating maybe negative impacts for the environment. Here, these types of standards are important. Often they are then closely linked to regulations or substitute regulations. Here, for example, in the IT security context, one example is that one IT management standard, ISO 27001, was more or less implemented one by one by Korea as a governmental regulation. Standards reduce variety, and more or less every standard reduces variety. Also the compatibility standards, if you think about the plugs or the interfaces now to the charging system of your mobile phone or your computer, is now meanwhile kind of reduced to more or less one variety, also pushed by the European Commission. And variety reduction allows mass production, cost reduction, which is increasing market efficiency. And in general, this is good for us as consumer. In some areas, probably standards are not so appropriate because we still like some level of variety. Then finally, standards provide information. They are codifying knowledge, and this is also important. Makes it easier to write contracts, because if you source products and you refer to a specific standard, you have not to really specify every detail in these contracts. You just refer to a specific standard. And in general, these standards combine all these different functions. They reduce variety, they have some content, and then either they are more focused on compatibility and interface kind of characteristics, or on the other hand, maybe more on quality and safety aspects. And that's more or less an overview for today on types and function of standards. And this will be then the base next week when we look at the role of different types of standards in the kind of research and innovation process, because here we also can kind of consider these different types of standards and look at which stage, which type of standards might be relevant to have you as researcher also to improve your kind of research. On the other hand, what we'll also address is the transfer from research results into standards. That means it's a kind of a circular process from research to standardization, and then using standards in research, etc. This is kind of, I hope, full to show you then this is a virtual circle which kind of benefits also researchers and not only companies. That was it for today. Thanks for your attention, and I hope that I can welcome most of you, or maybe all of you, next week again. Thank you very much.